Hey, hello friends. Welcome back to another video. So friends, in today's video, we will try to understand how does artificial general intelligence actually work. That is AGI actually work. So friends, let's see what are the core technical approaches which AGI generally is based on. So basically, artificial general intelligence, that is AGI, is currently a hypothetical version of AI, and it is supposed and it can perform any intelligent task that a human can perform, right? So unlike today's narrow AI, today's narrow AI is specialized for single tasks like identifying faces or generating a text, right? Apart from that, AGI would be able to learn, reason, and apply that knowledge across any domain without being specifically trained for each one. So if we go to the core technical approaches, as currently we do not have any true AGI, but researchers are pursuing several main strategies for building it. So basically, connectionist, that is neural networks. So as we are aware, this approach mimics the human brain structure using multi-layer artificial neurons. As we know, human brain contains multiple layers of neurons, and each neuron is connected with each other, and then the information is passed between the neurons, right? So the connectionist approach actually works on mimicking this behavior of human brain, right? Where the artificial neurons can be generated, and those can be tried to mimic the human brain behavior. Most modern systems like large language models, that is LLM, use this method to learn pattern from massive data sets. So as you are aware, any LLM to learn and everything, right? It needs a massive data set, and based on that can create data. Then we have symbolic, that is logic based approach. So this approach focuses on a rule based reasoning where human thoughts are represented by expanding network of logics. That is kind of a if-else statement, and it is excellent for transparent step-by-step problem solving. But when it comes to the real life data like vision or sound, it is very difficult to understand or solve those problems, using the uh, if-else kind of statement. So even if you just think about this situation where you are trying to have if-else scenarios, how are you going to teach AI to, understand the sound or understand the, the vision related information using simple if else? So it will need a lot more than that for having this information, right? Then we have some hybrid system, right? So like many experts believe that AGI will require neuro-symbolic AI, basically, so which combines the pattern recognition power of neural networks with the logical rigor of a symbolic AI. So the current AI, whatever is there, it is very strong logically. So logic-based approaches can be very nicely handled in existing AI. But when it comes to the pattern recognition power, the most efficient thing is a neural network because it can transfer the information, it can store the information, and it can learn from the patterns, right? And with every new information, the new neural connections are built, right? So that is a hybrid system. Then there is the approach of universalist. So basically, this is currently a purely mathematical approach, and it seeks a single master algorithm capable of solving any problem in any environment. Basically, like a human, you have one master algorithm which can solve any problem belonging to any environment. So these are some core technical approaches which are currently being considered for building AGI related systems. So let's see now some of the missing key capabilities which currently AGI is facing. So basically, to reach a human level intelligence, AGI must master several skills that current AI still finds difficult, right? So basically, one of such skills is a transfer learning. Basically, in human, if we let's say if we have learned a certain skill in one of the area, let's say like playing chess or any other skill, basically, right, or any language or something, right? then we are able to apply it to completely different area also, right? Like we do not need at least some basic concept, or we can find the similarities. We can apply it to other areas also. Like basically the example which I was saying is like learning a skill of playing chess and the concepts or finding similarities or the strategies and everything, right? In our work area, like completely, which is totally different area, like managing the supply chain and everything. So this skill is very essential in working across domains, right? Like across multiple areas. So again, this is one of the skill which currently AI lacks. Then basically a basic common sense, right? Like they say, like common sense is not very common, right? So basically, humans are very easily able to understand the obvious things, right, about physical world. So for example, let's say if we drop a glass, it will break, right? So this is just a basic information. Once we learn it, it applies to all the objects, right? If the material is glass, and basically a lot of other areas also, like something is prepared of mud or something, right? Or any of the kind of brittle material, if it falls, it will break, right? Now, it seems very basic to us, right? And very intuitive. But when you think from technology perspective or from the AI perspective, these basic things are also very complex, uh, and like currently AI lack this contextual intuition, right? So then common sense is one of the point. The embodiment, like some of the researchers argue that AI needs to have some kind of physical interface or a virtual body to learn through the interaction with the real world, right? Rather than just reading text on a screen. So let's say if AI wants to understand, like say, a difference between water and let's say any kind of oil, petrol, diesel, or something, right? Basically, then there's a then there comes the physical world, right? Like just by looking, you will not understand. Like if the color is same for water and any other kerosene or white kerosene, right? Or any other white transparent material like turpentine or something, right? Which looks similar to water, right? So then there will be some other human properties which you cover, like smell, touching the material, right? Understanding it and everything, right? So basically, then there come our sensors, right? The sensory system, like basically, it needs some physical interface with the world. So rather than just being present in a virtual world or being present in a hard software, or just reading a text on screen and everything, that will not help there, right? So again, many researchers believe that there will need to be some kind of a physical interface which AI will need. And then casual causal reasoning, basically. So understanding why something happens, cause and effect, right? Rather than just predicting what usually comes next based on the statistics, right? So currently, the whatever AI models are having, those are evolving very fast, and they are able to do the fair amount of reasoning. But again, this is based on something which is at least fed in the data or which has been learned by the LLMs or something, right? Using the AI models or predictive models and everything, right? But something which is totally different, which cannot be thought, but very creative, right? Uh, that reasoning still AI needs to achieve, right? And that will be very crucial when it comes related to the AGI. So these are some of the missing key capabilities which will be needed by AI to basically uh, to be successful at AGI. So we can see the properties which we saw. So one of it was a transfer learning, right? Then we have something which is uh, then we have something which is basically a common sense, right? Then embodiment, causal reasoning. There will be some others also, but yeah, just for some examples, we can mention these things, right, for understanding purpose. So yeah, so these are the missing key capabilities which will be needed by AGI. Wow. Hello friends. So basically, now let's see what is the benchmarks and testing. So as we know, it's hard to define like what exactly intelligence means, right? So, so that's the reason researchers use various tests to say if system has reached AGI, because uh, something might be intelligent in a perspective. but it's difficult to define exactly what is meant by the intelligence, right? Basically, there were some tests which were suggested by researchers to check if actually AGI can reach the intelligence level. So one of the tests is a copy test. So this test was proposed by Steve Wozniak. So as we all know, Steve Wozniak is a very famous uh, co-founder of Apple, right? Uh, he was a very intelligent person. He was actually brain behind the entire Apple uh, computers and associated products and everything, right? So he suggested a test like a machine should be able to enter a random house and figure out how to make a cup of coffee using whatever it finds, right? So basically, it could be just water, black coffee, milk, or whatever the materials it's able to pound, right? It pounds the coffee beans, and then there is no ready-made coffee, right? And then it should be able to figure out you should put the grind the beans and everything. So it's kind of that thing. It's a kind of a real world scenario where if you enter in a random house and you want to make a coffee, then what will be the steps which will be followed, which will first try to search like where is the kitchen and everything, right? If it already has the coffee, it already has milk, water and everything. This was one of the real life tests. Then basically then there is another test which was suggested like ARC-AGI. So this was a benchmark designed by Francois Polit. For this test, we fluid intelligence by asking AI to solve visual puzzles, which it has never seen before with very little training. So again, this comes to the solving something without any training, right? So, for example, if many times we see a new game where we do not have much idea, but then we learn by playing, right? So nobody has trained us, but we just see it and we just try to make sense out of it, right? And then we try to see, I mean, how does it what are the rules and everything, right? So that is one of the tests. So if AI is able to do that, then that was one of the tests. Then there was a very famous test known as the Turing test. So basically, Turing test is a classic test where machine should be able to hold a conversation, uh, and it should be held in such a manner that the next person that to whom that machine is talking with, he or she should not be able to identify whether he is talking with a real human or a machine, right? So basically, uh, so basically, it should be in such a way that uh, it should be so natural and everything, right? So that it's difficult for next person to mention to identify whether he is talking with a real person or it's talking with a machine. So that was one of the tests which was suggested by researchers. So basically, these were some of the uh, standard tests which were suggested, right? So suggested for the testing of the AGI, right? So basically, if we consider about the key takeaways, so basically the key takeaway is like most experts view today's AI as an emerging AGI or a proto AGI. So as we know, whatever we have whatever we have the uh, current AI, right? So basically, it's the emerging AGI only. Like as we all know, like whatever AI which we're currently dealing in computer, mobile, and everything, right? Everybody is trying to make it more and more like human friendly and more wider, right? So basically, that's the thing which has been planned. So it's a kind of proto AGI, but it can converge, but it still lacks the true reasoning and ability to operate autonomously in the real world, right? We have seen it in a certain environments, in certain areas, right? Researches and everything. But when it comes regarding the real world, nobody knows like how that will be behaved, right? Obviously, there will be research ongoing onto that. But currently, till now, that is still under the kind of a progress, right? So these were some of the benchmarks and testings which were designed for the AGI. So we'll continue with the next slide. So let's see now how the AGI is there in the telecom industry. So basically, in telecom industry, AGI represents a shift from automated networks to autonomous networks, right? So basically, today's AI can follow scripts to fix known errors, uh, because we design it in such a way that we can feed it some pre-designed scenarios and what will be the solution. Basically, it's kind of it handles known scenarios, and we go on. Then when we face newer scenarios, we can improve it basically. But again, it doesn't adapt to the random scenario which might occur in a real life, right? So the AGI would be able to diagnose and repair the totally unique network failure which it has never seen before, much like a senior engineer, right? So basically, the target is to that if we consider AGI in this field, so let's say out of sudden some random error comes up which we have never faced previously. But the thing is that it should be able to adapt it, it should be able to understand it without any prior training regarding that error. Looking at the scenarios, looking at the surrounding, it should be able to find it and it should be able to accordingly solve that error. So this is kind of something which is being considered as a AGI in the telecom industry, right? So industry, basically the telecom industry is moving through various changes of intelligence to reach a fully autonomous state. Basically, currently also in a telecom, there are a lot of things which are being tried so that without any human intervention, the solutions can be provided, right? So the current narrow AI system use self-optimizing networks to adjust 5G signals to predict when the cell tower might fail based on the fast data. Again, this is a narrow AI, so it relies a lot on the data. So based on the previous scenario, situation, weather conditions, or the network load timings and everything, it will try to decide like when is the kind of a possible failure scenario which might occur, right? Uh, so now in 2026, when we are discussing like moving into this year, basically telcos are trying to deploy AI agents that don't just alert humans, but also it takes the action. Basically, kind of a self-healing network, so that it do not just detect a fault, but it tries to correct it also, right? So something like where the let's say there is some issue in the network, so system will try to along with the uh, highlighting it to the specific people, system will try to repair it also, right? This is the next step basically, which will be considered in telecom. So that along with the handling of the scenario, it will try to repair it also, right? So basically, a rerouting of the traffic on a sudden local event and resolving 80% of the customer. Let's say there is some network bandwidth crunch or something has occurred, then basically without any human intervention, it will try to resolve the issue. So that is the one of the thing. Like future AGI would be basically AI native network where AI acts as the brain of the event of the entire infrastructure. Basically, it is able to perform the cause domain correlation, cause domain reasoning, right? So basically, correlation is also one of the very big factor which is used in the telecom, so that it is able to find the associated issues. If the issues occur in one area, then it should be able to kind of link it to the other area issue where it should be able to identify by its own that okay, there was certain issue occurred, so that's the reason this issue is also being seen. So something of that sort it is considered as a future AGI. So this is what is about AGI in telecom industry. So let's now see some key impact areas in the telecom. Basically, the key impact areas is a zero touch network operation. So basically, AGI's goal is a self-healing network that requires zero manual intervention. So basically, assume a network where it is able to self-heal itself. So forget the physical uh, issue like network getting damaged due to very large environmental issues and everything there, or the vortex will be needed. But the other issues, right? Like uh, if there is any issue seen, if there is any bandwidth crunch and everything, that is currently also being achieved. So basically, there is a concept known as root cause analysis, where instead of humans digging through logs and everything, if it is the data, the AGI could use a chain of thought and reasoning to connect the dot of between seemingly unrelated glitches across the radio access network, core and cloud layer. So, for example, let's consider that there are some scenarios where, let's say, there is issue in the physical cable and that cable is sending data over a wireless in some other area of the world. right? So if any mobile network is not working properly, or data connection is not proper, then basically it might be look very unrelated, but it might be possible that as there is an issue in the cable network, it has caused the issue in the wireless network also. So basically, for this kind of AGI, will try to understand like what are other issues being seen, and accordingly it will try to improve the or debug the issue and accordingly solve it. So this is one of the then again, hyper slicing. So it could dynamically create a network slices, dedicated virtual lanes so that the for specific needs, such as temporarily high priority lane for remote surgery or a fleet of autonomous vehicles and everything, adjusting parameters in a millisecond. So rather than human sitting and providing the data as per need and everything, AGI can try to provide the details, and it can basically quickly change the bandwidth allocated and everything as per within limits, and then that can be considered as a one of the scenario, right? So basically, these were some of the other key metrics. Now we can see some more also, like semantic communication beyond 6G. So currently, 5G is considered now. There is 6G also. So traditional networks send bits, zeros and ones, and try to reconstruct them perfectly, right? So AGI driven technologies could use semantic communication, which sends the meaning of the message. So rather than sending the actual as it is message, it can send the meaning of message, and it can basically send that the data. So this could bypass the current physical limit, allowing to massive data compression because the AI are both in understand the context of the conversation. So where we do not need message word by word, what can be done is rather than sending the entire data as it is, the message can be sent, then its meaning can be sent, and that could be helpful, right? So that is also one of the scenario considered in the AGI, yeah, right? So that is one of the key impact areas. The next one is basically the sovereign edge intelligence. To reduce the latency, AGI capabilities are being pushed to the edge, closer to the users. So technology sovereignty is basically the countries are investing in sovereign AI to ensure that their national telecom infrastructure isn't dependent on the foreign box model, focusing on secure locally government media. So basically, if any technology is being considered from any other company, then definitely there's a dependency on that country. Like let's say India is getting some software from USA or some other country. I mean, India has dependency on that country, right? So it's always tried to go technology locally so that there is a very less dependency on other area where the AGI can have a very huge impact. Then there's a real-time decisioning, like processing happens at the cell tower or device level, right? So enabling instant responses and the 6G applications like holographic calls or XR and everything, right? That is also one of the scenario of the key impact areas. So basically now if we consider the financial context, so as you understand now everywhere 6G and other technologies are being considered, and also AI is entering every area of the life, right? Or the area of the technology also. So basically the market for AI or AGI in telecom is exploding uh, very rapidly because providers seek to lower high costs and high costs of maintaining complex 5G and 6G grids. Right, so that's the reason the market will continuously grow. The AI in telecom market is projected to grow from 1.34 billion in 2023 to over 42 billion by 2033. Right, so in these 10 years there will be huge growth in AI using because telecom is also kind of a dependent usually on technology and everything, right? So there will be a lot of improvement from the AI perspective, right? Now next thing is efficiency gain, right? So earlier of this report, 10 to 20% reductions in network operating costs and everything, right? So basically because the issue resolution is faster, the penalties are less and everything, right? That's the reason it is kind of a very useful and very uh, uh, cost effective technology which will be AGI, right? So basically, so the key points if you consider the transition to 6G is being designed as AI native, right? So when 6G comes, it will have an inbuilt AI, right? So basically, AGI will not be an add-on tool, but it's the actual foundation of how network functions. So basically, networks will also have brain. they understand what is the situation, and they can adopt by itself only, right? Without waiting for any other technology or any other person or human to take action. It will be mostly it can try to become independent based on predefined rules, and can try to learn and evolve also over the time, right? Basically. So again, these are the financial context. So friends, this was additional information regarding AGI, and this is a trending topic, and basically, this is a technology which will affect every area of life in coming years and everything. So I'll try to prepare some additional videos